Okay, we have a function f of x, and I'm going to plug in for x 5i, the imaginary number 5i. And so I have f of 5i, and I replace x. Wherever I see x, I replace that by 5i. I'm going to write this as 1 plus 5i divided by 2 minus 5i. And it sort of looks like we're done, but I'm going to simplify this. And what I mean by that with complex numbers is I'm going to write this in a standard form. And the standard form is a plus bi. At least some people call that the standard form. So I want to write in a plus bi. Now, what's going on is the denominator is a complex number with an imaginary part, and I want the denominator to be a real number. That's going to get us to put this in standard form. So we do this technique, which is we multiply the denominator by its conjugate. Now I have a little note here. What is the conjugate? If I have a plus bi, the conjugate is a minus bi. So the conjugate of a minus bi is, of a plus bi is a minus bi. And if I multiply a plus bi times a minus bi, let's see what we get. A plus bi times a minus bi is a squared minus bi squared. Now remember that I squared is equal to negative 1. So I get a squared minus b squared, I squared. Eventually you can just follow, you get a squared plus b squared. So in this case, I'm going to multiply by 2 plus 5i in the denominator. Now, if I multiply by 2 plus 5i in the denominator, I want to multiply the same thing in the numerator. And so the result is, in the denominator, I have 2 squared plus 5 squared. You're welcome to multiply that out using FOIL in the denominator. It's shorter if you take the 2 and the 5 and you square them and add them. In the numerator, I'm not so lucky. I have 1 plus 5i, and then 2 plus 5i, and I need to multiply that out using FOIL. So I have 1 times 2 plus 1 times 5i plus 5i times 2 plus 5i times 5i. In the denominator, 4 plus 25. All right. So, of course, you can do a lot of this in your head, and it might look a lot nicer, actually. But here we go. Now, I squared again is negative 1. So I'm going to replace I squared by negative 1. In the denominator, I have 29. And so I'll have 2 plus 5 plus 10 is 15. And then 25 times negative 1 is just negative 25. So that's going to equal 2 minus 25 makes negative 23 plus 15i, all divided by 29. And I should write this as a real part. It's a real number. So that'd be negative 29, 23 over 29, plus 15 over 29i. I'm wondering in the back of the book whether they even did all this for their solution, but that's what we're supposed to do. Okay, so that's turned out to be a long problem. I mean, it was easy to put in 5i for x. It was writing this in a standard form that was difficult. So we used a plus bi times a minus bi. Its conjugate is a squared plus b squared there. That's to write that in standard form.